Hello, my name is Dr. Tiffany Bannworth from Bannworth Academy. I'm here with Dr. Joshua Mathews, who is the paleontologist from Burpee Museum in Illinois.
Yep.
But he is also the head paleontologist for the Hanksville-Burpee Dinosaur Quarry, which is where we are right now. And he's the permit holder for 2 counties in Utah. So we're going to ask him a few questions today so that students, in case you want to get into paleontology, you know exactly how to do it from an expert himself. So, you like to be called Josh instead of your formalities.
I do.
So, let me ask you this. When people say paleontology, they immediately think dinosaur. But could you tell me what paleontology entails?
Yeah. Paleontology is the study of ancient life, whether that's dinosaurs, mammals, birds, or pollen, plants, bacteria, microorganisms. It's basically anything that was living at one time. It's the study of how they lived, when they lived, and the story of what we can decipher through the fossil record.
So there's a lot of niche microspecialties that anybody interested in paleontology can kind of fall in love with and dedicate their life to.
Mm-hmm.
Now, this is the Hanksville-Burpee Dinosaur Quarry. What is scientifically significant about this site?
Well, this here is a massive dinosaur bone bed. So this particular deposit starts, as far as we can see, starts where we're at right now, and it goes for at least 1 mile to the northeast. And it's all the same layer. It's all the same bedding plane, and there's multiple dinosaurs, at least 20 dinosaurs buried here together, representing at least 7 or 8 species of dinosaurs. And that's based on a number of species, but also like a specific bone from a left or right side of an animal. So if I have 20 left shoulder blades, that means I have at least 20 animals in the quarry. So it's the minimum number in the quarry. I believe it's probably a lot more than that based off what we found.
Wow.
But until we can go through all the bones, get them prepared, cleaned up, and identify them properly, it's hard to say for sure. However, this is the Morrison Formation, so this is a data point in the history and the knowledge of what we know of the Morrison Formation. It's latest Jurassic. It's one of the most heavily studied dinosaur formations in the world, but this is a data point to help us basically contribute and piece together what the world looked like during the late Jurassic.
Right, and this is a Jurassic era site, so thanks to pop culture and movies like Jurassic Park, these are actually the dinosaurs that people are familiar with, instead of, just some obscure ones, even though I do know that you did say that there was an obscure one out here. What are the top 5 dinosaurs that you can expect to find here?
I'd say the top 5 for sure, 3 of which are sauropods, so the long-necked dinosaurs. So we have Diplodocus and Camarasaurus, I'd say, are the 2 most abundant in the quarry, with, off the top of my head, probably relatively equal numbers based on certain elements. Then Apatosaurus, and then surprisingly Allosaurus. Allosaurus, the big meat-eating dinosaur, the main predator of the Jurassic in this area, is relatively abundant. And when I say abundant, we're not talking dozens, but I have parts of at least what I believe are 5 Allosaurs here in the quarry, and they range from relatively small to quite large based off of some of the material that we found.
So what's the most surprising thing you found out here?
The most surprising one is a dinosaur we call Maimarapelta. Maimarapelta is an armored dinosaur. So armored dinosaurs, the most common one we know is Ankylosaurus. Now that was in the Cretaceous. It's the one that has this massively armored body, kind of like a tank with legs and a giant tail club at the end. Now the Maimarapelta in this quarry is much older than Ankylosaurus. It's part of a branch of Ankylosaurs called Nodosaurs, where they do not have a tail club.
Oh, wow.
So it's just a regular tail. Now we don't have the tail. We have primarily what we call osteoderms. Osteoderms, you can see them today in living crocodiles and alligators.
Oh, yeah.
If you look at their backs, you can see almost these square plates along their back, and those are bone that are embedded within the skin. So osteo means bone, derm means skin, so bone within the skin.
Wow.
So these animals had tons of osteoderms covering their body. That's the armor. And we found about 30 or 40 osteoderms in a part of the quarry. We found elements of the limbs. This year we found some vertebrae, so there's,
incredible.
It's very tiny, it's very small in comparison to these long-necked dinosaurs. However, it's unique. There's only been a few specimens found, and this is, I think, the second one found in Utah.
Wow.
So it's very rare.
Well, as the director of paleontology at a museum in Illinois and the sole paleontologist of this site and the two counties, you know exactly how to become a paleontologist.
I do.
And I know I have lots of students who would love to follow in your footsteps because you're living the dream.
Right.
So could you give us kind of an idea on how somebody not only do that they, because I understand you didn't start out with dinosaurs.
I didn't. I started out with invertebrates from the Paleozoic, long before the dinosaurs, brachiopods, crinoids. So I'm from southern Wisconsin, and much of the Midwest is, the bedrock is Paleozoic rocks. We don't have dinosaurs there because the rocks that they would have been preserved in have long been eroded away. They're no longer present. So when I was in college, I was a biology major and a geology minor, and unfortunately when I started there was no paleontologist at the university I went to. However, about halfway through my degree, a geologist retired, and they hired a paleontologist who studied brachiopods and these invertebrates, and I immediately went to him and asked if I could do research with him, just for my senior research and to get some background, and he absolutely, with open arms, let me in, and I spent the last few years of my degree working on invertebrates, paleoecology, sampling sites like this, only with invertebrates, and then screen washing them and sorting them in their different taxonomic groups, and then coming up with the paleoecological studies. So that was my first experience with research in paleo. I was obviously, when I was a kid, I wanted to be a paleontologist.
With dinosaurs? Or
with
just in
dinosaurs,
general?
I did. I loved dinosaurs. I wanted to be a dinosaur paleontologist. However, I didn't have that avenue. I didn't know how to get there. And even though I did paleontology as an undergraduate, my professor wasn't kind of piped into the dinosaur network or the vertebrate paleontology network.
I know you're telling me relationships in the field are very important.
Absolutely. If you get an opportunity to go to a talk where there's a paleontologist coming to speak at your school, or within your community or somewhere close, go to see them speak. A lot of times they offer meet and greets, so you can go up and talk to these folks and discuss their research. If you have a natural history museum or a museum of any sort near you that has a paleontologist or has someone interested in science, it's a good way to get your foot in the door. Volunteer. I started out as a volunteer at the Burpee Museum over 20 years ago.
Wow.
Literally.
And you've been at this site 18 years.
Yeah, yep. Been here since the very beginning. But it started with me reaching out to the museum saying, hey, I'd like to test my hand at, fossil prep. Is there an opportunity? And most museums, even the big ones, rely on volunteers. There's just not money to pay someone, or a lot of people at least, full time to clean dinosaur bones. So if a museum near you has a paleontology program where they're actively collecting, they're likely going to need someone to clean the fossils.
Right.
So volunteers say, hey, I'm available this specific time, and that gets your foot in the door. And it just doesn't get your foot in the door just for fossil prep. You start to learn how museums work. A lot of people think of museums as places with dusty animals, just old things, which some of them are, but they document the history of some form, whether it's the history of life on Earth, history of your community, whether it's a local community. It tells a story of what's been going on, in a particular place. It's kind of like a library.
Yeah.
It goes back, and you can look through time, whether that time is hundreds of million years, 1,000 years, or decades or centuries. It's a place to go to learn, and getting your foot in the door, volunteering shows you're interested in this. You're willing to dedicate some of your time to come in and give back to the community, and enjoy it at the same time. I mean, I wanted to work on fossils, and I was thrilled to be working on fossils. But then when people come by the window, you can open the window and talk to them and explain to these other little kids what you're working on.
Start that fire.
Yeah, exactly. And then they can touch an actual fossil. I remember the first time I worked on a dinosaur fossil. The first time I touched it with my tool, I was about freaked out because I thought I was in trouble. But it's just kind of figuring out how this how process works. And I would say, get involved in your community if you have one. Unfortunately, a lot of communities don't have something like that. And mine was further away from my hometown than I'd like, but it was still there. When you go to school, if you're interested in paleontology, the cool thing about paleontology and scientists in general, and probably most of us, is we would like to know people are interested in what we study.
Oh, that's true.
I mean, so if we get an email from someone say, hey, I read your paper, you know, and wants to discuss something, you're like, yay, somebody cares, you know. So you know, it's nice to hear from people when they read a paper, or they just want to know how to get into it. So conferences, if you're an undergraduate, if you're in college, for my field, there's a Society of Vertebrate Paleontology, and they hold annual meetings somewhere, typically in the U.S., every year. And unfortunately, it is expensive if you can find funding to get there. It's usually 4 or 5 days of talks about all groups of vertebrate animals, fossils, and all these paleontologists. So it's a way to go introduce yourself. If you are an undergraduate looking to get into graduate school, it's where you look for someone with common interests. So if you love Smilodon and you go to the SVP meeting and there's a bunch of talks on Smilodon, look at the authors on these talks or these papers, go meet them, introduce yourself, say, hey, I'm interested in this. I want to go to graduate school. Are you accepting students in the fall? And if so, how do I apply, and what do I need to do to be, you know, potentially selected for your lab? So it's about establishing a dialogue with these people. We're all normal people, you know, and I was, you know, when I was a kid, I looked up to so many of these paleontologists that, you know, I see them on TV shows on Discovery Channel or National Geographic, you know, and I looked up to these folks, and I wanted to be like them. And here I am 20 years later, having dinner with them,
Oh,
you know,
that's
going
incredible.
out, you know, and it's, you know, it's surreal. But once you realize, you know, everybody's just like I was, they were just like I was back then. So it's establishing a relationship, a conversation, especially if you're applying to graduate school. If you're undergrad looking towards graduate school, email these folks, because some of these schools get so many applications.
Right.
And
if you're a nameless, you know, faceless name.
Exactly. If, you know, and they're going through stacks of applications, which they might have 2 spots for or 3 spots for. If they're sorting through them and they see a name that catches their eye, they're like, this person emailed me. I'm going to set this one over here for now. It's a way to pull your name out from the stack and let, you know, that's what it's about. And that's a big part of getting towards a goal. I say establish a relationship, and make sure it's somebody you want to work with. You know.
Now, Dr. Mathews has given us permission to email him, so
Yes,
I'll be posting
absolutely.
up his email. And would you mind saying your email too?
Yes, it's joshua.mathews@burpee.org. So it's joshua.mathews@burpee.org. And Mathews, my name is with 1 T.
Is it?
Yep.
Oh,
So most
I'm glad
Mathews
you
have
said
2
that.
T's. So make sure you have 1 T in there. So joshua.mathews@burpee.org.
My name is Bannworth with 2 N's, and everybody puts 1 N.
Yep,
So
exactly.
I'm picking up slack
Yep,
for you within the letter department.
Exactly. It happens a lot. Hey, I emailed you. I never got anything back. Well, probably because I didn't get it.
It's been an absolute pleasure not only to speak with you now, but to be working for you for a week. It's been
been great.
excellent, life-changing experience. I recommend that everyone come out here.
Absolutely.
And if you want to follow or find out more about him, he's actually been interviewed by Dr. Beast. So there's a video floating around of you. in the Hanksville-Burpee Quarry with Dr. Beast. And he shared with me they even gifted you a tent.
Yeah, he did. You know, when I came out, you know, they send a whole crew out, and you know they fly in, so this equipment, they ain't gonna haul it back. So
That's incredible.
So they gave me the tent and a few other.
We got a celebrity on our hands.
No, not quite that.
Well, in my eyes, you are.
Well, thank you.
So I thank you guys for listening in and then to this video. It's available on BannworthAcademy.com, and you can also find us on YouTube. Thank you so much, and have a great day. Have a dino day.
Aha.